for a positive real number k, let ek be the ellipse with the equation x squared upon a squared plus k plus y squared upon b squared plus k equal to 1, where a is greater than b and both are positive, so obviously it is going to be a horizontal ellipse. All members of the family of ellipses ek, k greater than 0, have the same foci, eccentricity, pair of direct traces and center. Now this was a multiple select question, so we had to decide individually for all 4 options. Although MSQs will not be there for this year, but I thought of including this in our practice MCQs. Look, can I say that no matter what value of k you take, all of these ellipses will be centered at origin, right? Because that is in the standard form. So option D becomes true even without solving the problem. Just by merely looking at the equation, you arrive at the conclusion that the centers of all the ellipses should be same. Okay, so that option is there. Now obviously the second or the next question that we should attempt is finding the eccentricity, right? Because for foci we will require the product AE, and for the pair of direct traces we will require the ratio A by E, correct? So it boils down to finding the eccentricity of the ellipse, and suppose we have this ellipse. Okay, I'm just writing down the formula for you. For this ellipse, the eccentricity E, or okay, let me first write it in the form of b squared. B squared is given by a squared into 1 minus e squared. Okay, b squared is equal to a squared into 1 minus e squared. Now in our case, what is b squared? It is b squared plus k, correct? It is b squared plus k. Also, what is a squared in our case? A squared is this, a squared plus k. So let's put it here. Let us put it here and try to find the expression for eccentricity. If it is independent of k, it would mean that all ellipses have same eccentricity. If it depends on k, we have to conclude that eccentricity does not remain constant. Okay? Fine. Now we want to simplify this. B squared plus k upon a squared plus k equals 1 minus e squared. E squared is equal to, okay, so shift that term to LHS. Take the LCM, so that will be a squared minus b squared upon a squared plus k. Now what you realize is that eccentricity is a function of k. Eccentricity is a function of k. So do you think that eccentricity will be constant? No, eccentricity will not be constant. So option B is gone. Eccentricity is no longer constant because it depends on k. Right? Now let us decide whether it is foci or direct traces. Can any of these options be right? Look. Now when it comes to the product AE, okay, when it comes to the product AE in the original notation, in this case what should it be? It will be root of a squared plus k, because x squared's denominator is a squared plus k. So if I were to compare it with this blue a squared, for finding a I must take the root of that. So that will be root a squared plus k. Okay? Into eccentricity. For finding the eccentricity, go to the square of eccentricity and then take its root. So it will be root of a squared minus b squared upon root of a squared plus k. Okay, this value, this ratio, which cancels root a squared plus k, and then you realize that AE is independent of K, right? AE is independent of K. What does it mean? It means same foci. Okay, the foci will be same. Now, do you think that the pair of direct traces will also be same? No, they will not be same, right? Because product A is independent of the K, so foci is right and pair of direct traces is not right. If you are not yet convinced, then you can try with taking A by E. You will realize that you realize that A by E will also be a function of K. Okay, A by E will also be a function of K. Now what we can do is, let us go to GeoGebra and see whether indeed the foci remain the same if we vary K. Okay, let's do it. Squared by, now let us take A squared as 9. And let's take that B squared as 4. Okay, so this is now allowing me to change it from -5 to 5, but because our K is positive, let me keep it to 0 to 5. Okay, now let us go to the focus of this conic. So the two points AB are the foci, and let's also go to the direct traces equation. Okay, now let me change the colors here. Now what are we expecting? We are expecting that if the value of K changes, points A and B don't move as per our conclusion, but the direct traces will definitely move. Okay, otherwise option C will also be right, but our conclusion says it's not so. Let's check that. Okay, now see, the ellipse is changing as the value of K increases. As the value of K increases, the direct traces go away from each other, and as the value of K decreases, the direct traces come closer to each other, but the foci do not change. Okay, the foci do not change. Eccentricity is changing, foci do not change, so that kind of confirms our answer, right? That they have the same foci and of course same center, but different pair of direct traces and eccentricities.